Hi, welcome back to my channel. So today we continue chapter 6, Light and Optic, on the first part, 6.1 Refraction of light. Okay, this situation, I think you will observe it almost every day. So you put a spoon into the water, you can see the spoon appear bends in water. Or you put a glass block, you can see suddenly the words of the book become bigger. Okay, so why is this situation occur? What concept that we can use to explain this situation? So that's the concept that I want to discuss today. It's about refraction of light. What is the meaning of refraction of light? As we know that light always travels in a straight line. That's why our line of vision also is straight line. So what is the meaning of refraction of light? Is the bending of light due to change in the velocity of light when traveling through mediums of different optical densities. So when there is change in the density of medium, it will cause change in velocity. When there is change in velocity, it will cause direction of the light to bends. Look at this ray diagram. So this is incident ray, maybe coming from a ray box, incident towards a glass block. So you can see the light ray travel from air to glass. The line that separates the two medium, which is less dense medium, you can say air, or the denser medium, we can say example as glass. So this line is a boundary line that separates the two medium. So when incident ray is incident at this point, what we do is we draw a normal line. A normal line is 90 degrees to the boundary. The angle between incident ray and normal line is angle of incidence. What happened to the light ray? If no change in density of medium, the light ray will travel in a straight line. So this is the line that will be passed through by the light if no change in density, this broken line. But now there is change in density, so this is denser medium. So you can see the light ray bends. So in this case, light ray bends towards normal. So this light ray, we call it refracted ray, and the angle between normal line and refracted ray is angle of refraction. Okay, now let's discuss further. What happened to the light ray actually when travel from less dense to denser or denser to less dense? Okay, in this case, we have air and glass block. You must understand that this concept, I think you all know that glass is denser than air, meaning the density of glass is higher than density of air. Okay, look at the first diagram here, this ray diagram. Incident ray, incident towards the glass block, meaning light ray travel from air to glass, less dense to denser. At this point, we draw normal line. So you can see here, the light ray bends towards normal. Okay, so you can see how the light ray deviates from its original path. This broken line actually is the line where there is no change in density of medium. So you can see how the light ray deviates from its original path when there is change in density. So for this one, we can explain by using this explanation. When light travel from less dense to medium, less dense medium to denser medium, what happened? Velocity of light decreases. So what happened to the light ray? Bends towards normal. So you can see the angle of refraction R is smaller than I. Okay, next situation, the second situation. Now the light ray travels from glass to air. Okay, so at point of incidence, same thing, we draw a normal line. So this is angle I. And what happened to the light ray in this case is the light ray bends away from normal. So you can see this line actually is the original line when no change in density. So you can see how the light ray deviates from the original path. Okay, so in this case bends away from normal. Okay, so when light travel from denser medium to less dense or rarer medium, light ray bends away from normal. This is caused by velocity of light that increases, and this one will cause angle of refraction R bigger than angle of incident I. So you can see here R is bigger than I. Okay, the different cases of refraction. So let's say this is a glass block, the blue color. If we incident a light ray along the normal line, meaning perpendicular to the boundary, this is air, this is glass, so this line actually is the boundary. So the light ray incident along the normal line, meaning I equals to 0. Okay, what happened to the light ray? It will travel in a straight line without refraction. Okay, but velocity still decrease in glass. Okay, so for denser medium like glass, light travels slower. For less dense medium like air or water, light travel faster. So in this case, when I equals to 0 or light ray incident along normal line or perpendicular to the boundary, we get angle of refraction equals to 0, meaning there will be no change in the direction for this case, but the velocity decrease. Okay, and then the second one, this is the ray diagram. Incident towards the glass block, this is angle I, so you draw a normal line here. So what happened to the light ray? From air to glass, speed decrease, thus bends towards normal, so the value of R becomes smaller. Now the light ray continue to travel to this point and then coming out or emerge from this point. So you can see the angle I here is R for this light ray. So what happened from the glass to air, speed increases again, so the emergent ray, you can see that come out here, will refracted away from normal. Okay, so this situation, different cases of refraction.